Today I shall discuss about geotechnical engineering, a brief note on geotechnical engineering. Before starting the original subject, I would like to state some opinion and views of great geotechnical engineers all over the world. First, I would like to mention here the comments of Showers, a great geotechnical engineer and scientist. He had made specific comments as an overwhelming majority observes no more than an approximate forecast is needed. And if such forecast cannot be made by simple means, it cannot be made at all, since soil complexity is a metaphysical phenomenon like existence of Brahma in our soul. Another Professor Winterkorn of Princeton University had commented one. The language transmission of street soil during excessive vertical loading has been the most difficult task as the sufferings are no less than a dying patient. Another comment it was made by Scott and Bowles. It is very difficult to ascertain whether the behaviors of foundation depends primarily on soil characteristics or soil behaves at the will of foundations like seed plant phenomenon. Yet the behaviors of underlying soil has a substantial role in the construction management. Scott had made specific comments on settlement. The settlement of a foundation, the most uncomfortable and objectionable phenomenon in the construction management, cannot be overpowered merely by theoretical estimate alone, as the mineral skeleton breakdown may not always proportional to time elapsed. Another great comment was made by Carl Tarzaghi, the father of the soil mechanics. Neither soil mechanics, a theoretical science, nor mathematical science, as it is a practical science based on intuition only. Another specific comments of my reverend guru, Dr. A.N. Dr. Chaudhary, who is a student of Professor Winterkorn in Princeton University. In his project report, he said this: till now we are ignorant or incapable for actual estimation of soil foundation interaction system either. For this reason of lack of computable knowledge, we do more commonly prefer to adopt a full factor in the name of safety, even with no hesitation of putting huge quantum of concrete underground, while misleading information and immature interpretation of principles are root of all major structural damages. Dr. Carl Tarzaghi once also commented, a test is worth a thousand wise opinions, since the geotechnical engineer is a science of integrated knowledge of experience, imagination, judgment, simplifying and idealized assumption beside competency in geology, mineral science, and construction management. In fact, these comments I have presented here to, to you so that you can understand what is geotechnical engineering. In earlier days, geotechnical engineering, formerly known as soil mechanics and foundation engineering, the science of engineering soil and the behavior in foundation, although youngest science is neither a mathematical science nor a theoretical science, it is a science of reasoning and intuitional judgment. So, the soil mechanics is the arts of civil engineering. Every structure except flying or floating rests on soil. The relation between soil and foundation is geotechnical. In ancient times, structures were built using some principle. Nowadays, these principles are termed as common sense, based on some earlier information, which are basic sources of today's analysis. In respect of technology development, for example, soil slope stabilization with plantation of Ashoka the Great, hydrogradient of Maharishi Vyasdev, erosion control and flow determination, etc., are unique and still useful. Geotechnical engineering was first published and popularized in 1925 after publication of the Mechanics of Earth Construction based on soil physics by Dr. Carl von Tajagi, where he said the method of nature must be considered in the light of intelligence and experience because the soil contains many various elements, and so he is called father of soil mechanics. Geotechnical engineering covers the science of soil mechanics, soil engineering, rock mechanics, engineering geology, foundation engineering, hydrology, everything. It is an essential and integrated part of civil engineering. Modern geotechnical engineering even covers geo-environmental engineering and geoecology and geolandscaping too. Soil is necessarily formed, although unconsolidated aggregates of disintegrated or decomposed particles of rock mineral grains with little bondage or without any bondage, and available at our art crust for reasonable thickness. The difference between soil and rock is bondage only. All the mineral constituents are remain same. In rock mass, the bondage of grains are strong and permanent. In is soil has no at all bondage of grains or very poor. Soils are divided mainly into two groups, residual and transported. The soil which are transported by river, glacial, wind from place of origin to another place, it is called transported, like alluvium of river basin. Soil which remained at the same place of origin is residual. The hills are other than structures. In engineering application, soil is divided into two groups, fine grained soil and coarse grained soil. Fine grained soils are the finer the 75 micron and coarse grained sand from above 75 micron and furthermore. Here less than 2 micron, it is less than 2 micron, it is clay fraction, and 2 to 7.75 micron, it is silt, and 4.75, it is gravel, and up to 80 mm. Some says it is 70 mm, and some says it is 75 mm. However, from 70 to 80 mm it is gravel, and up to 300 mm it is cobble. It is cobble, and below 300, above 300 it is called boulder. But in geotechnical engineering, a particular important factor is there. The gravel, cobble, and boulders are also considered as gravel, not as a cobble, not as a boulders, because the engineering properties of gravel, cobble, and boulders same as that of gravel only. So it is considered gravel, cobble, boulders as a gravel only. Later, this type of soils, coarse grain and fine grain, or whatever it may be, these are considered in three groups: poorly graded, well graded, and with a little of binders, that is fines. These are poorly graded SPGP, well graded SWGW, and with little binders, that is SC, SM, GC. These are the, yeah. In addition to these, the fine grain sand soil also classified in three different groups. These are: one is low plastic, such as Cl, Ml, Ol; medium plastic, Ci, Mi, Oa; high plastic, Ch, Mh, OH. There is no well-defined boundary line of some of the soils like Ci and Mi, Cl and Ml, and Ch and Mh. Although the experts have suggested and defined some principles, what is called A-line curve, depending upon the plastic limit and liquid limit. But these A-line principles are not globally accepted whatsoever. In particular applications, hardly any difference. In this space, I am trying to avoid more details about theoretical analysis. Basic concept and practical application is discussed here, so that it will be primary informative to the young engineers, especially young practitioner engineers. We must not forget that soil mass is a complex natural materials, and each soil exhibits different characteristics at the same location. Notwithstanding, we assume that the soil is semi-infinitive, soil is isotropic, soil is elastic, soil is homogeneous, soil is weightless, and it has no past history. At the same time, I would to like one thing. Soil has different meaning too. For an agriculturist, soil is the surface material where which supports vegetation and plantation. For construction engineer, soil is a construction material for construction of highways, roads, pavements, and these things. And the coarse grain soil is construction for used for, as a construction material for other purpose also like concrete structures, runways, roadways, in all this. For geotechnical engineers, soil is a complex substance of the earth crust. Whether it is complex or not, but for us, we consider it a complex since soil does not behave according to our own will, to our desires, to fulfill our desires. Soil never behave as per our requirement. Normally, we shall we shall discuss about the application of the soil parameters. Application of the soil parameters. It is since all type of structure rest on soil. That may be a shallow foundation at a normal and standard average soil, deep foundation where shallow foundations could not be provided, such as at riverbed, very soft soil up to a reasonably high extent. So before discussing the main application, we must know how to derive our design parameters. Let us say for construction of a shallow foundation or deep foundation, I have already discussed what difference between the deep foundation when foundation width by depth by b is greater than 1, df by b is greater than 1, it is shallow foundation. No, it is deep foundation. When it is equal to 1 or less than 1, it is shallow foundation. For deep foundation or shallow foundation, we require Sbc. In the case of pile, we require pile load capacity based on same parameters. For, for that purpose, we require our Sbc. Then Sbc required parameters we can estimate it from laboratory test. For laboratory test, we should go for field test. These are boring and observation. The above analysis reflects the requirement of field investigation and observation and laboratory research for designing foundation base of any tower foundation or building foundation or well foundation, whatever it may be, for any type of foundation. The general concept of QA plus minus M by Z, which shall be greater than 0 and less than SBC. The equation may be written as Q by A, that is the derivative. Now M by Z, it is very simple. Now lot of computer aided programs have been developed. So in earlier days we have to calculate very precisely and in a long process. Now it is very simple. Within one day one can design it. SBC, SBC, the shape bearing capacity is the maximum load bearing capacity with a suitable safety factor without any excessive settlement. In early days, Dr. Carl von Tajagi had recommended the safety factor of tolerable limit as 2, allowable limit as 3. Later, Peck, Hanson, and Thunberg also, they have recommended a safety factor of 3, while Indian Road Congress has recommended 2.5 against dead load and 2 against combination of all loads. The Bureau of Indian Standards does not recommend any specific value and suggested to decide on judgment, but preferably not less than 2.5 in first publication in 1971 and the second publication in 1981 and 2000. No such specific value was recommended. In some countries nowadays consider the safety factor as a reliability factor to accommodate the probable instrumentation errors and human error in computation. In earlier days, in 1960s, it is called Fool's factor, not safety factor. It is called Fool's factor. That means if there are some big mistakes, big amount of mistakes are there in collection of samples, in laboratory tests, and immature computation, then safety factor should be taken as more. And if chances of mistakes are very less or negligible, then the safety factor may be 2. There are several methods of determination of Sbc, that is QA. Out of these methods, more popular methods are Q and C5 method, plate load test, SPT values, and stress-strain relationship. Initially, Dr. Carl Tarzaghi had used unconfined compressive strength and N values for estimation of safe soil pressure, and in 1925 he had established the empirical relationship between unconfined compression and confined shear test. The unconfined compressive strength of soil mass, the ultimate compressive resistance under unconfined condition, thus Q equal to applied unit load tolerable deformation not exceeding 20% of the specimen length. When the lateral pressure is 0 and cohesion C is defined as the maximum applied unit load under control condition, sigma 3 equal to 0. Produced by adhesive force of particles, grains, and frictional angle is the angle of friction between the particles, grain, under deformation. And from these relationships, there are two methods, the QU and C5 method. C is a constant, QU and safety factor. Constant is varying from 2.85 to 3.57. Tarzaghi has recommended 3.5, 3.57 for square and circular foundation and 2.85 for continuous foundation. And the C5 method, C and C, Q and Q, and half B, gamma and gamma. These are NC and Q and gamma. These are popularly later on when used, it is termed as dimensionless Tarzaghi bearing capacity factor. After a few years, Tarzaghi had find out that these equations are based on ground level only. not much below. So he has included uh, Kazagi peak and Tanban. They have applied some other factor, shape factor, depth factor in the original bearing capacity. Another method is plate load test. Plate load test is a, nowadays it is considered as a physical verification of theoretical estimate. But earlier, plate load test was conducted for finding out the design parameters, and more importance was granted on plate load test than other uh, theoretical calculation and from laboratory test results. So plate load test directly conducted. This is the arrangement of the plate load test. This is the loading plate, and there will be some dead loads, and settlement shall be measured sensitive dials, minimum 2, or you can put 4 also. In case of 4 also, there shall be a two-stage computation. One is diagonally, another is other direction, 4, plus taking average of both direction. That will you have to calculate this settlement. But this settlement good for shallow foundation when df is equal to b, and this is some drawbacks is there. There are it is a very short time loading, and our smaller plate size, maybe 600 by 600 or 750 by 750 Some cases, some cases 1.2 meter or 1.25 meter can be used, but our foundation size is much bigger than that. There are a lot of empirical equations to convert the settlement of the settlement of the plate, small plate size to actual foundation size. There are a lot of empirical valuation in IS, also IS 8009 part 1. There is the equation B plus 30 and BP plus 30, like that. There are some equations are there with that equation also. Very nominal difference is there. But in normally consolidated clay, uh, mostly everyone is suggested width is directly proportional to the settlement. If we are 60 size plate size is using there, and our foundation dimension is 6 meter, then 10 times more. But actually it is not 10 times more. In case of normality consolidation also, theoretically, if we calculate, theoretical value will be much less than 6, if it is 6 and foundation settlement will be 60 But theoretically, if we calculate, if it is 6, from plate load test for 60 plate size is less, then it will be much lesser than that. I have this, the variation and dependent factors of the derivatives D, B, Bf and Bp, that I have make the separate analysis there. One day I will discuss that also, what is normally differing. So normal cases, there are a lot of yeah, the Ball's equation is most reliable. It is B by Bp to the power n. N varies from 0.3 to zero point 0.7. Whereas some say that n value should be 1 or more. Whatever it may be, I have discussed that portion in my later discussion. And but this is another, this is another, this is Bowles and Scott. They have recommended. This is the elastic limit. It is the uh, load versus load versus settlement. This is the settlement. This is the load. This is the elastic limit, and this is the tolerable limit, and it is the failure limit. If we plot this line, in log scale, in this side also, I shall make it clear to you. If it is a log scale, both sides are logs. You see this portion straight going upward. Here it is gentle upward slope. Here it is straight line. It is elastic limit. This is plastic limit, and this C is shear failure. Here it is, there is a shear fail, so no further load can take. The same load, it will be continued. If we are putting more excessive load also, ultimately the pressure gauge will be coming here on log scale. This is straight line, and this is straight going upward tendency. This portion has a straight going upward tendency, and this portion has a upward tendency, but it is very gentle, very gentle. Here it is 2 division, here it is 4 division. For crossing 2 division vertically, horizontally will require 4 division. So this portion is plastic limit, and this portion is elastic limit. This portion is shear failure limit, shear failure zone. So accordingly, they have suggested this against this elastic limit, it should be 2/3. Here it is half, and here it is in shear zone. Here it is 1/3. If we write it, instead of 1, if we write it 2/3, this is the safety factor: 2/3, half, and 1/3. In the elastic limit, in the elastic portion, if we consider it is the ultimate elastic limit, then 2/3 is sufficient. Since the elastic settlement is settlement when it will take a rebound state, there is a possibility of rebound state. Even seismic condition also, if it is uh, if it is due to earthquake vibration, if one side is uh, releasing some load, that means if it is uh, M by Z became it is negative side, that is lower side, or it is higher side. In all cases, the settlement will remain same, since the soil also following the load behavior, since it is within the elastic limit. It is compression limit, that is plastic limit. Plastic limit, half safety factor is good enough. But here 3 is required. 3 is essential. Now you see SPT value. This is the oldest method of determining soil pressure. SPT, the standard penetration test by dynamic loading with a 65 kg diaphragm and from a free fall of 75 centimeter for 30 centimeter penetration of standard split spoon sampler. This sampler has earlier known as Tarjagi sampler. Now it is called standard split spoon sampler. So, however, this is the first basis of determining SPT. In earlier days, before popularization of soil mechanics and foundation engineering, earlier days, a known weight of a rod was allowed to free fall to penetrate inside the ground, and they will measure and they will calculate how much it will take for 1 inch penetration, what should be the actual limit. So that is the crude method of SPT. That was the crude method of SPT which was used up before 1925. After popularization of geotechnical, that is soil mechanics and foundation engineering, the SPT method was first adopted for estimation of Sbc. Now our Indian Standard 2131 has adopted also this SPT method, and IS 8009 Part 1 also adopted as value SPT method for determination of settlement, and settlement, assuming settlement is directly has relationship directly with the Sbc. So from settlement Sbc can be recalculated. There is some empirical relationship also. I am giving it here. These are all empirical relationships. This is also it is Professor Winterkorn had established this relationship with a correction of B in the foundation width. This is another equation also. This is also this. The stress-strain relationship is the latest development of Hooke's law. Hooke's law defined that the stress is proportional to strain. This is elasticity of a material. So with the stress-strain relationship, we can calculate Sbc from the relationship of settlement. Settlement can be estimated with this is PBI, this is elastic, and 1 plus mu square. We can calculate from this, and here one thing is very important. It is applicable for hard clay. Other than hard clay, it is not applicable. And this, you see, this is some amount of interpretation. In case of interpretation, one should be cautious. If we put B, S is either directly proportional to P and B, or B, both. If we increase the both P or a constant P, if we B we are increasing, our S will be directly increased. If we same size, if we are increasing P, S will be according to the increment. So, since it is directly proportional, during computation we should be cautious. We should be not exactly uh, not we should not exactly be conservative, but we should be very careful during application of this equation. Number one, it should be very hard soil where shear failure should be a governing criteria. There are two types of failure. One is shear failure, another is settlement failure. In case of settlement failure, we are lucky enough because settlement is a time dependent factor. But in case of shear failure, we are unfortunate since shear is very all of a sudden. Nobody can nobody can understand what happened. When fine morning one will come and see that building has been collapsed. But in case of settlement failure, it should be gradual. We are getting sufficient time. Shear settlement failure, failure, it is that like of a steel, and shear failure, that fail like that of a concrete. That is sudden failure. There should be no chance at all. So we should very much cautious to this extent. Today, up to this, I am finishing my discussion up to this section, and in coming days I shall discuss from here of the next portion. Thank you. Please have a nice day. I hope it should be useful for new practitioner engineers, and last year, uh, that means final year student too. Please have a nice day. I can be reached at jcguru@gmail.com.